Welcome to the homework help video for, or whatever I'm calling it. I don't remember what name I gave it this quarter, but where I just do a couple homework problems and walk you through it, give you the opportunity for some extra practice. So I highly recommend you try all of these before watching the video on that problem. We're going to start with number 3. Again, please try it before you look at the video. And this is finding the domain from the graph. We're also going to get some practice finding the range, even though the question only asks for the domain. So remember that the domain is all the inputs. Usually we think of those inputs as x coordinates. So we see, well, what's the furthest to the left we can go? And what's the furthest to the right we can go? And do we have everything in between? So in this case, the furthest to the left we can get is -5. The furthest to the right that we can get is +3. So in interval notation, we write it like this. +3 is not included, so it gets a parenthesis. -5 is included, so it gets a bracket. And then again, interval notation does mean everything in between, so make sure that every input between these 2 points exists. And yeah, there is every x value between those two does have a y value, so this will be our answer. You can see that we got it right. And if we did range, it'd be something similar. We'd say, what's the smallest y value? Well, the smallest y value is a y value of about -4. And what's the biggest y value? Well, there's a y value of -2 here. It doesn't matter that there's a circle here, because there's still the y value that's attained here. So if we did want to write the range on this problem, then we'd say the range was -4 up to -2 inclusive. All right. And that's that problem. Next up, I want to look at number 5. Find the domain of this. And again, this is using set builder notation, which we didn't really cover, but it's pretty similar to what you might expect. We want to find the domain. So the domain of a fraction is going to be all the points where the denominator is not equal to 0. So this function, and again, you're going to have to write this out. You can't do this all in your head, so make sure you have paper with you when you're doing homework, is x plus 3 divided by x squared plus 5x minus 14. Again, the domain is all points where the denominator, because this is just a simple fraction, there's nothing else going on, the denominator is not equal to 0. So we just try to find out, okay, when is the denominator not equal to 0? We solve this quadratic equation. Quadratic formula, completing the square, factoring. These are all some different ways that you can solve this equation. All right, I think factoring is probably the easiest. This is a trinomial, means there are 3 terms. And the coefficient of this guy is 1. There's no number next to the x squared. That tells us it's going to factor in this way, where this is an x and an x. And now to fill in the blanks, we need 2 numbers that multiply to the last term, -14, that add to the middle term, the middle coefficient, rather, of +5. If you need more practice with factoring, let me know. I can give you a couple of places to go, or you can use the quadratic formula to solve this. All right, so we need 2 numbers that do this. Let's see, -1 and 14. Oh, that doesn't work. -2 and 7. Oh, that does work. So just list a bunch of factors. One of them is going to have a negative, factors of 14. This will be a -2 and a +7. And we can check our answer by foiling first, outer, inner, last, and multiplying this all out and make sure we factor correctly. So this is going to be true when x minus 2 is not equal to 0, and when x plus 7 is not equal to 0. Add 2 to both sides, x can't be 2. Subtract 7 from both sides, x can't equal 7. Sorry, -7. And those will be our answers. So the domain is going to be everywhere except for 2 and -7. So this is going to be our choice. Again, this notation is not super important for this class. But you can see that, oh, it says x is not equal to -7 and x is not equal to 2. All right. And if it's multiple choice, you can also just kind of try some of these out. Can we plug in x equals -14? And if you plug in -14, you will get an answer. So that can't be the answer. This can't be the right choice because -14 is in the domain. Domain is all the numbers that we can plug in. But if you try to plug in -7 or -2, you're going to divide by 0, which is a big problem. All right. All these other ones, you can plug in any of these numbers that are shown here. So they can't possibly be the correct choice. That's another way of approaching it. But that only works if it's multiple choice. The way I did it in my my work over here is the best way to do it. All right, last problem I want to look at over here is number 7. Sketch a graph of this piecewise function. Not a super important skill for this class, but a medium important skill. All right, lightly important, let's say. All right, so this is 3 pieces. So these are all lines. The line y equals 0 is a horizontal line. The line y is x plus 1, it's a diagonal line. The line y equals +1 is another horizontal line. So we're just going to draw each of those lines and then make sure that each line is only visible on that piece. So here's what I mean. So let's start by drawing this first line, the line y equals 0. Any line of y equals a number is a horizontal line. And so we're going to select this tool down here and write it like this. Okay? So that's the line y equals 0. But this is a piecewise function. We only want to have this line when our input, when our x value is -1 or to the left. So we need to essentially erase a lot of this line. This should be the right edge of this line. So again, think, if you want to think about this as drawing with a pencil, you can draw this whole thing with a pencil and then erase everything to the right of -1 because we only have stuff to the left of -1. We're only on this line to the left of -1. All right. So we can switch over to this tool, which has one direction, and say, all right, we're starting at -1, and we're going as far to the left as we can along that line. We're trimming it down. All right. And then again, it says, be sure to include closed or open dots when there are breaks in the graph. So we'll worry about that at the end. Next is a line y equals x plus 1. Again, this one's only going to be between -1 and +2. So we're only drawing a portion of this line. It has a y-intercept of +1 and a slope of +1 as well. So it starts here and it has a slope of 1. And we're only going from an input of -1 to an input of +2. And you can double check that this is that line. You can plug in some values, right? If y is equal to x plus 1, we can make a little table. And that can be another way to help us draw this line. If x is -1, what is y? It's going to be 0. If x is 0, what is y? 0 plus 1. If x is 1, y is 2, and if x is 2, y is 3. And you can see that all of those points we've drawn here. 2, 3, 2, 3, and so on. The last up, we have this last piece, y equals +1. That's another horizontal line with all the points where a y value is +1 to the right of 2. So that'll be, again, one direction. The y value is +1, and it goes to the right, like so. And so that has our 3 pieces. We're at the y value is constantly 0 up to -1. And then between -1 and 2, between x values of -1 and 2, we're on this diagonal line. And then past that, we're at a y value of +1. Constant y value. Now we just need to make sure that we're reading all the instructions. When there are breaks in the graph, include closed or open dots. So there's only a break in the graph one place. This is the only place where the graph is not connected. So which one gets a closed dot and which one gets an open dot? It depends on the inequality. So we're on this diagonal line all the way up to +2. And then we're only on this horizontal line strictly bigger than +2. So that one's going to be an open circle. And now we should be good to go. Let's see how it likes our answer. We got it. Let me know if you have questions about any of this. Good luck and have a good rest of your day.